Alright, we're going to try one more time making a video. This time doing it with a video camera. We're going to give you basically I'm going to teach you how to do area under the curve, which is 15.3, and the fundamental theorem of calculus, which is 15.4, and they both are done the same way. It starts with doing the antiderivative. So maybe I should start by reviewing how to find the antiderivative. Alright, so I'm going to go over here. Try to switch hands, sorry, with the video camera. I'm going to flip over. Antiderivative, in order to find it, you need to start with, let's say we start with 3x squared, okay? This is the function. We want to find the antiderivative. To find the antiderivative, you need to add to the exponent and divide by the new exponent. So we added to 2 to get 1, and then divided by 3. Well, then 3 divided by 3 cancels out, and you get x cubed plus c. This is the antiderivative, all right? Hopefully that made sense. Alright, now we're going to go back over here now, back to the book. And it's going to refocus. Okay, so on this lesson here, basically going to see that they're trying to find the area under the curve. And they're doing it by big rectangles here, or smaller rectangles. And if you sum them, you would get the area, but not the accurate area. The only way to get the accurate area is to find the integral. Now the integral is the fancy word for this symbol right here that you'll find on page 962 of your book. And it's that symbol right there. See, let me see if I can get my finger on it. There it is. There right there. See how it has a little, kind of like a long S? All that is a way to write, find the antiderivative without having to write the sentence, find the antiderivative, okay? And it's called the integral. It's for a definite integral, which you'll see right there. Definite integral. It's definite because there's actually values A and B that you can plug in and get an actual answer. So again, let's look. Now if you look at the book examples here, you're going to find it's more confusing than helpful because they find a way to drag this out. The best way to find examples on even how to do the problems in this lesson, which is 15.3, is the best thing to do is actually to go to 15.4. If you look at 15.4, the very first example is a perfect example of what to do. You see it has the integral. I'm going to close in on it just so you can see better. It says, well, maybe that's too close. Okay, there it is. The integral, find the antiderivative of x cubed. Don't worry about dx, that's just extra stuff. So how do you find the antiderivative of x cubed? Well, you add 1 and divide by 4. Well, look at the example. What did they do? Oh, they added 1 and divided by 4. They got 1/4 x to the 4th plus c. That would be find the antiderivative. However, since there are two values here, 2 and 4, then you're going to take and plug those in. Now, this is fancy notation for plug in. Don't really worry about that either. Just notice, what did they do? They took 1/4, then plugged in 4/4. Then again, ignore the c. I never put on this plus c. That's an extra thing the book's doing that's not necessary. Minus 1/4 times 2 to the 4th. Okay, so what we're doing here is you're taking this minus this, okay? And that gives you the answer of 60, which you can see in the book. All right, let me take, and before you can see again more examples down below. Just ignore this section in your book here where it says power rule, constants and multiple, sum of the sum and difference rule. All those are rules that you already know. You've already been doing them. You just didn't know there were a name to them. So you're welcome to look at those for knowing the name, but it's not necessary. And again, you see more examples here. 5x squared dx is just find the antiderivative plus c. Notice there are no values to plug in. Therefore, you don't have to worry about plugging in values here. And then on b, you have the same thing. And if there's no values to plug in, then you do have to remember to put plus c. You're just finding the antiderivative. Again, the integral is a symbol that means find the antiderivative of this function. All right, finally over to this section. This section will look exactly like what's in the other one, but this is the easier way to do these problems. Again, 15.3 is the same as 15.4, but it's the long way to do it. And I'm telling you, it's okay. Let's learn 15.4 and use the short way to do the problems in 15.3. All right, so here's the problem. You've got an equation here that is x squared, and we're shading from -2 under the curve up to 1 above the x-axis. This is the shaded area. So to find the shaded area, you need to find the antiderivative of this equation and then plug in the high value minus the low value. What happens? Why is it the high value minus the low? Well, what happens is the high value, when you type that in, it gives you the area under all of it forever. Then when you take and subtract the area that's here from -2 and forever, what you're left with is what is in between. That's why you're subtracting the high number minus the low, so you get the area in between those two numbers. All right, just to make sure that was clear. So basically, again, let's go in and think about this. What are we doing? We're finding the antiderivative. Add 1, divide by 3. That's why they have 1/3 x cubed here. Yes, plus c, but since we have values to plug in, I'm not worried about the plus c, and I'm just going to plug it in. 1/3, plug in the 1 here, minus 1/3, plug in the -2. When you get done, your result will be 3, and that's how many units, unit squared is the area. All right, so there's that, and that's how you do that. So again, if you're looking at these in the book on, I'm sorry about that, on this lesson here, this is the area under the curve. You're going to do the antiderivative of the equation 2x squared, which means add, divide, add 1, divide by 3, so you have 2/3 x cubed, right? Your high value will be 3, your low value will be 0. So you'll plug in 3 into that new antiderivative equation, and then you'll plug in 0 and you'll subtract them, and that'll give you 18. You'll see that on my solution guide. These up here, notice there's the answers. Notice it doesn't have any values to plug in, so you're just going to find the antiderivative. And over here, same idea again. Just notice it's just giving us the equation. It's giving us the low value, the high value. So you're going to find the antiderivative, plug in 4, get that answer, plug in 0, get that answer, subtract them. Same idea. And again, here, same idea. They give you values that are plugged in. So they're already given. If you notice this lesson, again, if I went back to 15.3 now, which is what I'm doing, look at the problems in 15.3. The actual assignment, if I looked at it and I didn't know, you would think you're doing 15.4. And you can do these problems, which is not very many of them, but please just do them with the concepts learned in 15.4, not the long process taught in 15.3. Done.